Hey, I'm Hannah Weiss, the Education Manager at the Science Museum of Western Virginia, and this is your Moment of STEM. And this week, we're going to talk about Neptune and math, but mostly Neptune. And when we're telling the story of Neptune, there's actually another planet that it's really important to talk about, because the discovery of Neptune probably wouldn't have happened the way that it did without this other planet. The other planet that I'm talking about is Uranus. It's a really big part of the story of Neptune. So Uranus was discovered by Herschel in 1781. And from the time it was discovered, people, scientists, astronomers, had noticed oddities, kind of strangeness in the way that Uranus went around the sun and the way that it orbited. And there were a whole lot of ideas, a whole lot of theories put forth for this, but kind of two big ones emerged. The first was that, well, maybe that far out from the sun, Newton's law of universal gravitation didn't work the same way, it didn't apply the same way. And the other big idea was that there was this trans-Uranian object, an object past Uranus, that was doing something weird to Uranus's orbit. It wasn't until 1845 or 46 that two scientists really sat down to kind of figure this out. Leverrier and Adams both sat down and did these insane calculations, things that today wouldn't be so difficult because we've got computers. But at the time that they were doing this, were really tedious hand calculations, and predicted this planet just past Uranus that was doing some really weird things, that was tugging on Uranus's orbit. And Leverrier actually convinced another astronomer, Jonathan Gall, to go out and look for this planet, which, at the end of September, Gall did. And using Leverrier's calculations, he was actually able to find Neptune, this planet that Leverrier predicted. He was able to find it in under an hour of searching. This was incredibly awesome, and you'd think probably that the story ends here. But we have two scientists who both predicted this planet. And because only one of the scientists' calculations were really used, this touched off this huge debate between the British and French astronomical societies as to who was really owed the credit for the discovery of Neptune. Now, this is something that gets even further, more tangled when we look into it today, because there's some evidence that Neptune was actually observed before its so-called discovery. In fact, Galileo may even have seen Neptune without realizing what it was. There's also some evidence that both Leverrier and Adams, their calculations were awesome, but they, in doing them, got the mass of Neptune wrong, they got the orbital path of Neptune wrong, and actually even Neptune's distance from the sun. There's even some evidence that suggests that they were super lucky at the time period that they were observing, because at any other time, their calculations wouldn't have given us where Neptune was. But this is still an incredibly important discovery because it was the first time in astronomy that calculations were the basis for discovery and not direct observations. It was this incredible triumph of the scientific method and an awesome proof of Kepler's laws and actually Newton's laws as well. This all may have best been summed up by one of Leverrier's colleagues, who said that he discovered a star with his pen, without any instruments other than the strength of his calculations alone. If you'd like to know more about the awesome scientists that we've talked about today and their discoveries of Neptune and some of the stories behind their discoveries, you can check out some of the links below. I'm Hannah Weiss from the Science Museum of Western Virginia, and I finally got to talk about math.